Welcome to Programming Problems Episode 4. Let's have a look today at long swaps from Kattis. As always, we begin with the problem description. Today's problem is nice and short. Given a string S, we may modify this string by making long swaps. We can swap two letters if the distance between their positions in the string is at least some integer k. Now, if we are allowed to swap any number of times, possibly 0, can we sort all letters in S in increasing order? For the constraints, we only get a string S, which shall have length of at least 2 and at most 100, and an integer k, which is at least 1, and at most the length of the string minus 1. Note that the string shall only consist of lowercase letters. And that's it. Let's take a look at some examples. For the first example, k equals 4 and the string is prognova. It turns out that for these inputs, we can do long swaps to make these characters sorted. Please have a look at an example window where k equals 4 and the sorted string. Can you reason about why it is possible here? In example 2, the string is hello world and k equals 6. It turns out that on this case, we cannot sort the string by using long swaps. Please have a look at an example window of length 6 and the sorted string. Do you see why? Because there are no significant insights for me to give without spoiling the solution, now is a good moment for you to pause the video to try solve the problem. We shall continue with looking at the solution in the next segment. Let's begin. We'll look at both our examples side by side to observe a difference. Now let's see which positions we can swap using the smallest possible window. We'll start from the left with the window of k equals 4. Then we'll keep track of the positions which were swappable. In this first position, we see that we can swap the positions of P and N. Now let's move the window to the right. We can see that the positions of R and O can be swapped as well. Now let's do this once more. And then after our final step, what do we see? We can see, of course, that every letter was swappable to some other position using the smallest window. Now, for the second example, again, we start with the smallest window and slide it from left to right. Since now you know how to do this, I'll speed up the process. Now that we've marked all swappable positions, we see that two positions can never be swapped because we would need a smaller window, meaning that we need a smaller k. Now, this does not have to be a problem if the letters in those positions already match the letters in the sorted string, but for our example of hello world, they do not. Hence, it is not possible to sort the letters using long swaps for that string and a k of 6. But what about all the other positions? Can we arbitrarily swap any green-marked positions to any other green-marked position via one or more steps? It turns out that yes, we can. We will not do any formal proof in this video, but try to at least reason through this yourself, to convince yourself that this is indeed possible. How could you, for instance, move any arbitrary letter one position to the right or the left? Can you envision the steps? Now for the final part of the solution. We don't have to move the window and mark all the positions. We simply can compute which positions overlap by taking the intersection of the first k indices and the last k indices. If this intersection is not empty, then we need to compare against the sorted string to see if the letters match or not. And that is simply all there is to it. I hope you liked exploring this problem together, and as always, thank you for watching. Please do subscribe or like the video if you are enjoying the channel, and comments are welcome below the video. Have a nice day!